Yeah, I'm sorry, Rachel. I just made a mistake. This was just a typo. This was supposed to be D, not C. Okay, you can check your book and check the word. You should be familiar with this already anyway. Go through what I'm writing and verify. But again, it's BD over CD is equal to, is equal to CD over AD. Okay, we're taking vertical, and then we're taking horizontal. Then we come to between between this one and this one, okay? Between the original big triangle and the bigger of the two smaller triangles. So that way hypotenuse over hypotenuse equals CB, which is short leg, over DB over short leg, okay? So that works fine. And then we go the smallest triangle versus the original triangle. Okay, what does that tell you? Again, hypotenuse over hypotenuse, AB over AC equals AC over AD. So hypotenuse over hypotenuse equals long leg over long leg. Okay, so that's how that works. So now, look at something interesting. You will notice that in each of these cases, these two terms are the same in all these cases. And what does that suggest to you? Remember the definition of the geometric mean? Remember, if we say it's x, geometric mean of A and B, geometric mean of A and B being x, and that x is defined by that. So this suggests something to you. So in fact, it's telling you that CD is the geometric mean of these two. So look at it. So let's come and look at it. So CD, which is that, remember CD is the altitude that we drew to create this scenario, CD. Now CD is the geometric mean of BD and AD. Okay? So this is what they call the altitude theorem, the geometric mean. So they call this first one geometric mean, and then they put altitude in parentheses, theorem. Geometric mean altitude theorem. Why? Because it's telling you that the altitude is the geometric mean of the two broken up portions of the original hypotenuse. Listen to me again. The altitude is the geometric mean of the two broken up portions of the original hypotenuse. This is the original hypotenuse, remember, because that's the original triangle with the right angle here. So we drew the altitude, and the altitude turns out to be, if you break up, where the altitude meets the hypotenuse, it divides the original hypotenuse into two portions, AD and DB. AD and BD. And that altitude is in fact the geometric mean of the two broken up portions of the original hypotenuse. That should be easy for you to remember. You have an altitude, it breaks up the hypotenuse into two portions, and if you want then to show, if you were given this portion as A, this portion as B, and this portion as H, it should be easy enough for you to know that H is the geometric mean of A and B. H is the geometric mean of A and B. That is a theorem. It's called the geometric mean altitude theorem. Okay?